Patient care is more critical in present-day life, and we consider it as the most important aspect in deriving MISPA-i. Common tests like ASO, CRP, RF, HbA1c and add-on parameters like cystatin C, IgE, ferritin, microalbumin and lipoprotein makes it unique in its segment. The technology used in MISPA-i is an ingenious one. Nephelometry. Flexibility and accuracy are guaranteed when nephelometry comes to the picture. MISPA-i is one of the most ergonomic serum protein analyzer ever produced in industry. Automatic calibration, 3-step assay procedure, plug-and-play portability, and quick results are never available in a single package before the advent of MISPA-i. It's very critical in getting an excellent calibration in protein assays. MISPA-i is an economic solution for small and medium-sized laboratories for specific protein testing. In addition to that, it can be used as a standby analyzer in high-end laboratories. Each test done in MISPA-i is highly economic without any compromise in quality. We assure increased profit margins with less investment. Turn the power on. MISPA-i will take 10 minutes to warm up. This will happen only at the time of power up. Calibrating MISPA-i is very easy. Just insert the IC card. The calibration will happen automatically. This multi-point calibration guarantees accurate results. Reaction volume, expiry details, and lot number information are also included with the IC card. This avoids the extra requirement of a kit insert. If you want, you can print the test details by simply pressing the right button. To continue the test, press Enter. Then the display will prompt you to add both R1 reagent and sample. For HbA1c test, prepare hemolysate. Now, we will show you how to do that. Dispense 500 microliter hemolyzing reagent R3 into a clean test tube. Then dispense 10 microliter of whole blood sample into the same test tube. Wait about 10 minutes for hemolysation and use it before 3 hours. Dispense R1 with a 20 to 200 microliter pipette into the cuvette. And use another pipette of 2 to 20 microliter with microtip for the sample. Now you can place the cuvette into the cuvette holder and press Enter. Then the mixing will start by rotating the cuvette. Incubation is an inbuilt process which happens after the mixing. After the incubation, add R2 reagent as prompted by the machine. Use the attached electronic pipette for that. The electronic pipette will automatically trigger the final mixing and the subsequent measuring. Now, you will get the results in the display and as a printout. Handling procedure. If the equipment is out of printer paper, it will prompt you with a warning message. You can continue the test if you want to by pressing the Enter key, but the equipment will hang up after this test. You have to reload the paper roll whenever the printer error shows on display. We will show you how to do this. Please follow the procedure. First, Remove the printer lid. Then carefully remove the pinch roller. Put the new refill roll into the paper tray. Put the pinch roller back by gently pressing it. Pull the paper through the slit in the lid and put it back in place. Then restart the machine. Warm up required after every power on. You can skip the warm up if you restart the equipment within half an hour by simply pressing the enter key during the warm up period. That is, once the equipment got warmed up, you don't really have to wait for the warm up to complete for a power down duration of 30 minutes. The electronic pipette attached with the machine is only meant for dispensing reagent R2. Don't use it for R1 or sample. Hold the cuvette proper. Don't touch the light path area, it may affect the accuracy of the result. Hold it at the top. The IC card is an electronic device. Keep it in moisture-free atmosphere. Avoid keeping it in refrigerators along with the reagent kit. Discard the cuvettes after a single use. Don't reuse them. A series of comparative studies has been done to ensure the quality and accuracy of MISPA-i. These rigorous and impartial studies shows that MISPA-i can match any high-end clinical chemistry analyzer in the industry. As a proof, we are showing you some of the case studies. Comparison with HPLC method, HbA1c correlation graph. We compared HbA1c clinical samples with highly expensive HPLC analyzer and got a correlation coefficient of 0.985. Comparison with nephlometer. ASO correlation graph. 15 ASO clinical samples compared with an expensive nephlometer with cumbersome procedures. We got an excellent correlation coefficient of 0.987. Comparison with fully auto clinical chemistry analyzer. We performed 20 clinical samples of ASO, CRP, RF and found excellent correlation coefficients in all the cases. Toshiba 120FR ASO correlation graph. Toshiba 120FR CRP correlation graph. Toshiba 120FR RF correlation graph. BioList 24i CRP correlation graph. BioList 24i RF correlation graph. BioList 24i HbA1c correlation graph. Intra and inter-assay precision. We performed both intra and inter-assays with 3 different samples of ASO, CRP, RF and HbA1c in 10 runs and MISPA-i showed very less CV in all the cases. ASO intra and inter-assay precision chart. CRP intra and inter-assay precision chart. RF intra and inter-assay precision chart.